Alright, hey guys, we're just looking at how algebra works in terms of finding expressions to do with shapes. Okay, so the idea is if you have an unknown side of a shape, can you express it algebraically? And the answer is yes, you can. And in fact, it's the exact same way as you would a shape with numbers. So, first up, we have a square. Now, the way to find the area of a square is you do length times width, or you just do one side squared, doesn't really matter. Length times width in this case is a times a, which is a squared, which makes sense when you think about it, because that's the way the squares work. Let's have a look at this one. So again, it's length times width. So this is let's just say 6 times 2a minus 1, but it's that whole expression, so you have to put it in brackets. It's not just 6 times 2a minus 1, which is another way of writing this. It's like, well, what do we do here? Well, we did distributive law already. So we know that you just need to expand and distribute this 6 amongst both the things in the brackets. So we have 6 times 2a minus 6 times 1, right? Which is 12a minus 6. That's our expression, right? And I've tried to do one that was a little bit harder just to give you an idea of how this one would work, because this is a challenge, right? I guess do I have enough to solve this? No, I'd probably need... No, that could work. Okay. So I'm going to split this up into a couple of different shapes, right? So here I have this one shape is, one side is 2x, but without this additional 7 here. So it's 2x minus 7 multiplied by 3x plus 6, 3y plus 6, which is an expansion problem. This is probably not the best example for you guys, because this is not U9 algebra. So let me scrap that and let me just add an 8 in here, so it's a bit easier. Okay, so let's do 8 times 2x plus 6, right, which is 8, 2x plus 6. It's 16x plus 48 for this side, plus whatever's left over here. I have 7 times 6, which is 42. So I can say that my whole thing together is 16x plus 90. And that's my area for that whole shape. Anyway, you get the idea how it works. I wanted to try and keep this short and sweet. I'll quickly do, let's say, a worded problem just to finish it up. So let's say there was a theatre, right, a movie theatre, that had a whole bunch of seats. And I'm not going to draw each individual seat. Right, these are the rows of seats. And we knew that there was some number of seats, but we weren't sure what it was, so we're just going to put A, right? If there are 10 rows, right, and I added an extra bank of 6 seats onto the end, how could I express this algebraically for how many seats there are? Okay, so pause the video and give it a go if you think you can do it on your own. If not, I will do it now. Okay, so this side of the rectangle is however many seats we had first, which is A, plus the additional 6 seats, that multiplied by how many banks of seats there are, in which case there is 10. And this is a problem that we're used to now. We distribute the 10 amongst both of these. We have 10 times A and plus 10 times 6, which gives us 10A plus 60 seats. Alright, that'll do for now. You get the general idea anyway. Alright, thanks guys, enjoy the rest of your day.